Okay, so we're back then. Thank you very much for those of you who were here with our first half today. We're back for 3 more presentations for you now, all on the virtual summit here, our future of text analysis. So let me bring you our next speaker who's here for you. This is Sid Dhuri, who is Head of Advanced Analytics at Hiscox. He's the Head of Claims Advanced Analytics there. He leads a team of data scientists helping the claims operations with insights, with forecasts, and automation with the application of machine learning, modeling, and NLP techniques. He's also got a master's in data science from Ghent University in Belgium. He's previously worked across industries like machine learning to business outcomes. He's also the founder of Roxy AI, an analytics software platform, marketing automation, and analytics as well. This discussion is all about NLP with human in the loop AI. Quite a combo. Sid, how are you?
I'm doing good. Thanks for that great introduction, Richard.
Great to see you. If you have a presentation, I'll invite you to just share it for us now, and then you can get going.
Yeah, I'll do that. So let me start by sharing my screen. Let me know if you're able to see my screen.
Yep, that looks great.
Okay, that's great. So thanks for inviting me. I'm very happy to present here at the Future of Text Analytics. And what I'm going to talk about is something that we are trying to address the problem, to understand the pain and the claim for our customers at Hiscox. And we try to employ human in the loop AI. And I'll be walking you through how we are employing humans and AI together to solve some business problems. So what you see over here is a customer who's just bought an iPhone, and he's really excited. He's really happy. He's having a really positive experience over there with the Apple staff over there. He's going to go on social media. He's going to obviously talk all about how the great experience that he's having using the iPhone product and other things. Now, I work in the insurance industry, and I can't remember any customer going, yo, I just bought this new insurance policy. I'm so excited about it. In fact, we buy insurance policy to cover the exciting product that we bought. We bought a nice expensive phone, and hence I buy an insurance policy to cover that. So our products are not so much that key customers are going to go out and talk about how they like using our products. When the customers do talk to us, it's usually when they've experienced a loss and they're in a distressful situation. So you hit a car, you've done a car accident, and that's where you're in a painful situation, and then you want to file an insurance claim, and that's when customers reach out to their insurance carrier. And it can be quite a difficult situation. It's very important for insurance carriers to then understand the pain in the claim to help and solve the issues for our vulnerable customers. So, and where are customers interacting with us? So this is a survey conducted by ITDS, which is a consulting firm, and they found out that a lot of insurers are finding that customers are communicating them with not just like the traditional folk call-in media, but also using emerging social media such as Twitter, Facebook, and other emerging media. Twitter being one of the very popular ones where people expect an immediate response nowadays. And it's not always painful news from the insights that you're looking for. It's not always complaints or negative experiences that people are sharing on social media. There's also a lot of positive things that you can gain from doing all this and looking at all this data. So, for example, I worked in the pharmaceutical industry before. And even in the pharmaceutical industry, they're looking at user experiences, how users are using the products. What you see over here is the pill. It's a pill for Parkinson's disease, and Parkinson's patients, they find it very difficult to lift a pill if it's fallen flat on the table because their motor skills are suffering due to the disease. And if a pill is lying flat on the table, it's very difficult for them to lift it. And so this was an insight that they gained from analyzing people experiences of using the product. And so they designed this pill. And so what this pill is, it's a hexagonal pin, a pentagon pin with a fulcrum that is pointing. So this pill can never lie flat on the table. You can also see the blister pack. It has 7 blisters so that people can remember if they've taken a tablet for the week or no. So just what goes on to say that it's not just painful experiences, but really positive experiences that you can use in product or package design, developing patient adherence, understand from real world experience, and risk mitigation for insurers. Now, so there is people are interacting on social media and various other media, and there is really good insights that we can garner for that. So, what is the challenge? The challenge is the scale of the data. For us, we are considering data from loss narratives about the claims that customers are filing with us, the adjuster notes, various complaints that we get, the net promoter score surveys that we do, Trustpilot and FIFO reviews of customers, and last but not least, Twitter and other social media. Now, the scale of the information is really high and it's free text, so it's not easy to analyze quickly. So how do we try to analyze that in a more intelligent way? To summarize the problem, so let's say that I have documents, or let's say reviews that I've received from our customers, and I want to understand what are these comments talking about. If I have a really large corpus of either customer complaints or reviews, I want to understand the key ideas, key themes which are there in the underlying corpus. So if I look at the words that are present in these documents, I want to understand what are the latent or underlying topics. So for example, if I look at the documents which are talking about words like lawnmower, landscaping, gardening, these could be the claims or policies for professional indemnity. Similarly, documents which are talking about slip, fall, and trip, they are probably talking about a bodily injury claim. So this is what we are trying to do, looking at the content of the documents to understand the underlying topics. And one of the very popular or prevalent techniques for understanding topic in a corpus is called as LDA, which is the Latent Dirichlet Allocation. To give you an overview or understanding of what we are doing over here. So let's say that my corpus has 3 topics, sports, astronomy, and food. And just imagine them that they are at the 3 corners of this triangle. And if I get a topic, if rather a document that is talking about football, free kick, goal, I can place it in the sports corner. Similarly, if I get a document that's talking about solar, aura, and mercury, I can place it in the astronomy corner. Anything that is about pasta, sauce, or soup, I can place it in the food corner. Now, documents which have words like cricket or bat or catch, they could be talking about sports, or they could be talking about food, cricket, bat, or even a catch of the day, for example, fish. Any documents we're talking about Mars or orbit could be talking about astronomy, or it could be talking about food because of Mars bars or orbit chewing gum. So it's important, the words and also the underlying context of those words, to understand which topics would these documents fit into. A document that is talking about galaxy or stars could be either of the 3 topics. Astronomy, because obviously galaxy and stars; sports, because LA Galaxy football team or the football stars; and food, because of the galaxy chocolate bars, for example. Now, to give you the blueprint of the algorithm, how it works or what it is doing, so this is how it looks like. You have an input from the left over there, which is a collection of documents, and you feed them into this kind of machine. And if you see, the output is obviously the topics, 1, 2, 3, 4 topics that it's going to uncover from these corpus of documents. Now, if you see that the gray ball over there, the bit W, so that's the only observed element, which is the word. So looking at one word at a time, I want to place these documents in the various topic corners, and various other parameters like alpha, which is a Dirichlet parameter, theta, z, etc., are all estimated parameters. So the problem is, you take a corpus of documents. For every word at a time, I look at it and I want to estimate the various parameters. Mathematically, it looks like this. It's a conditional probability where I'm trying to estimate what is the probability of a word given the topic, and I'm using the Dirichlet distributions for topics over terms, then documents over topics. And I know that this looks a bit scary and a bit complex, but it's actually a bit more intuitive. And what I might say that you might have actually applied this algorithm in your real life. And let's look at an example. So let's say that you moving your house. So you packed all your stuff in from the old house and you put it into a truck. You arrive at your new house, and you've unpacked or unloaded everything in the new house. Now imagine that the topics being things like bedroom, living room, or bathroom, or kitchen, and the words being every item in that you unloaded from the truck. So all the items that you see on the screen right now, imagine them. These are the items that you need to place into the various topics. Now, I don't know where exactly each thing might fit, but I can see that if I look at one item at a time, like one word at a time, with with respect to which other word where I can place it. So let's say that if I say, look at the shoe, okay, I know that I can place it next to the shoe. Then I start with the hanger, I place it next to the other hanger. I find these trousers, I can place it next to the shirt over there. Um, I find a dining set, so I can place it next to the cutlery. Next, I look at the table, I can place it next to the computer, and then my chair also next to the desk, so that I can sit and work from home. And then if I find a couch, I can place it next to the TV, and the remaining shirt, I place it next to the all other clothes. So here I am without having a knowledge of where the things should end up in eventually. Just looking at one item at a time and assuming that everything else is in its like correct place, I'm able to give some sense of order to the chaos that was there. So this is actually the intuition of the LD algorithm that you just saw. How can I, looking at one word at a time, try to classify all the words into a collection of various topics? Okay. Now, what are the challenges with natural language? So natural language in all sense, it can be quite ambiguous. Many of the algorithms are developed on or trained on really beautiful language like Jane Austen or Sherlock Holmes or Shakespeare, for example. But we have to apply them in real world. We are applying them to a claims request or claims that or social media data that is generated by normal humans. And these languages will have a lot of ambiguity. So there can be lexical ambiguity with problems like homosemy, polysemy, where you have one word having multiple meanings or multiple same words having different meanings. And then syntactic ambiguity, semantic ambiguity, spelling mistakes, and even colloquial words which mean one thing in a given context. Lexical ambiguity, for example, the word pen has many meanings. It can be the writing instrument, or it can be a place where you keep animals, or even a playpen for babies, or pen is also for female swan, or pen can also be used as a verb meaning to write. Syntactic ambiguity. So, for example, the statement Sherlock saw the man using binoculars, or was Sherlock using binoculars, or the man was using binoculars? So, there's a lot of ambiguities in natural language that machines need to deal with. But humans are really good at this. So humans are really able to understand the context, especially given a domain that they work in. They can really help the machines understand that context behind all the free text. Um, the domain knowledge, humans know it quite well in their industry, but machines don't have access to it. But we need to encode it in a way where and make it accessible to machines. So one way to do that, what we are trying to do is something called as taxonomies. So what you see over here is a taxonomy for multiple sclerosis. So we take the concepts like drugs, side effects, or conditions and other things, and we try to combine them in a hierarchical structure. So for what you see over here is the various topics or like concepts like drugs, side effects. Within side effects, there's subtopics like vision problem, bowel, bladder, etc. And within that, you have even more subtopics. So it can be a hierarchical um, taxonomy. Similarly, a taxonomy for insurance claims can be like topics which could be the cause of losses, like bodily injury, cyber equipment damage, etc. And then within those, there could be various causes. So in this way, humans could encode their understanding of the domain, and then it could be used by the machines. Now, while the humans are creating a taxonomy from the domain knowledge, the machine can also help in bettering the taxonomy. So, for example, looking at the corpus, and while you are developing the taxonomy, the machine can make suggestions. So, for example, in this corpus, as the user tries to add words to the corpus, the machine will suggest some words. So, for example, boots. In the UK, boots is a pharmacy. Excuse me. So the user tries to add it to the topic drugs, and then the machine goes to the corpus, looks for similar words, and then it makes suggestions. So what you saw over here is that it found words which are similar to boots, like the strings which are very closely matching strings. Using algorithms like the Levenstein distances, it found that words like bouts or books are very similar, and it makes those suggestions. So over here, the machine is now helping humans to better improve or expand the scope of this taxonomy. Um, Once again, exploring context. So the application that we have also helps users to understand the context of words. So if the user wanted to understand, oh, what is the word needle? How is it being used? So if you can see from the examples, the word needle is used in the context of injections, but also in the context of the pain that people are experiencing that when they're walking and other things. So there's you can explore word how it is being used by the users in various contexts. Also exploring the correlations. So if we are looking at one word, you can identify with how this word is correlated with different other words in your corpus, and which are the words which are highly correlated. And so if you can imagine, this is like your Pearson's correlation efficient, where you try to identify in your variables which variables are highly correlated. Similarly, through your corpus, you can use the phi coefficient that gives you the words, two words, and what is the correlation between them. So this can help you identify words which are really come together or used together quite often. In this example, you can see that legs and steroids has a very high correlation. The reason being patients who suffer from multiple sclerosis. This document corpus is from multiple sclerosis patients, and they need to tend to use steroids to overcome the pain in their legs. And when you start creating or linking highly correlated words, like steroids will have a high correlation with some other words, you will form networks, and then you will be able to uncover various other concepts. So once again, the machine over here comes, looks at the words and helps you to uncover various concepts. So once again, then you can take these words, which the machine has identified as highly correlated words, to add it to the existing taxonomy that you had. So you're going and expanding your taxonomy. And once you built your taxonomy, you can use it to supply to the LDA, latent Dirichlet allocation. What it means is that when we saw earlier the LDA algorithm, it tries to classify topics using it's an unsupervised technique, so it has no knowledge. It just looks at one word at a time and tries to organize the words into various topics. But with the way that you are able to give some sort of prior knowledge through the taxonomy, it can give better results in our experience. So this is what you see over here is the LDA applied without any input from the users. So it's a vanilla LDA. And what we saw were that it was the topics that we were able to understand from a very plain vanilla LDA. They were not very coherent. We couldn't make much sense of it. So then we encoded a taxonomy for the data that we had, and we tried to apply that to LDA as a sort of a semi-supervised way. Let's see what were the results that we saw from there. So this is so same corpus, but we applied LDA guided by a taxonomy. So now what you can see, the topics were a bit more richer. So the topic one was talking about legs, walking, needles. So this was about the pain in the legs and walking that is experienced by patients. Then the second topic was talking about diabetes, insulin, high levels of insulin in their blood and other things. Once again, a very coherent topic. Then the other one was talking about steroids, eyes. A lot of patients were suffering for eyes and they used to take steroids. And similarly, and topics talking about diet, where they want to eat high in omega-3 acids diet. And the last topic was talking about insurance support from the government, benefits and other things. So the last topic was talking about how the support and the insurance around management of the disease. So what we saw that once we were able to encode the domain knowledge from humans and supply it as a taxonomy to be used by the algorithm, we were able to get better, richer outcomes from the LDA algorithm. Okay, so we've taken a corpus and we've I tried to identify the various latent topics that are there in this corpus, and so what can we do about it? Now, when you give sort of structure to unstructured data, you can use it for analysis. So, for example, um, um, after we applied the taxonomy that we had developed to our really large unstructured corpus, we were able to very quickly classify the discussion into what people are talking about. So what you can see over here is a sunburst diagram. You can quickly see that 12% of the discussion was about drugs, followed by 41% by side effects. And within the 41%, 2.9% people were talking about bowel bladder, and 0.8% people were talking about incontinence and loo. So as you can see, in a very quick time, we are able to give an unstructured corpus a structure and understand the underlying discussion that is happening, the topics that people are talking about, the words that people are using, and further, you can use it for different analysis, for developing heat maps, cross tabs, for identifying word correlations, identifying the share of the book of business. I mean, how many complaints, if I have a lot of complaints, how many complaints are for a part of the business, or how many complaints are for a specific product, for example. Similarly, for customer service training, so looking at the words and the concepts that people are using while they are communicating on social media or various other media, we can use that to train the customer service, so that when customers do talk to our customer service, they are better informed and they can have a better discussion. So once again, it's a mix of mind and machine. Starting from the humans start by representing their domain knowledge in a form that machines can understand, that is in a taxonomy. Then AI augments the human inputs with suggestions. So using various NLP techniques, the machine then offers suggestions to augment this taxonomy. Then the machine is able to model topics and relationships in the corpus, guided by this domain knowledge. And then users are able to explore the context and relationships of concepts within the document. So it's like a feedback loop between human and machine interaction, and that we have seen has been a very useful concept. And machines can get confused too. So we know that the machines, the amazing capabilities that machine learning has brought to human understanding, but sometimes machines can get some human help. I mean, looking at the pictures, is this a chihuahua? Is this a muffin? Or on the right hand side, is this a caramel ice cream, or is this a kitten? So yeah, machines could use some help from humans sometimes. And I'll end with this quote from Alan Turing: is that we can only see a short distance ahead, but we can see plenty there that needs to be done. So machines might be immensely powerful with the computing power and the algorithms, and compared to humans. But yes, humans can help machines do a bit better job. So that was me. Okay. Yeah, I hope that was good.
I'll just put a couple of questions to you, only because I've spotted it. Although I'm still not convinced that I got all of the Chihuahua and Muffin pictures correct there. Some very close calls. So Kyle has posted this one. He's actually put this in the chat, but luckily I've spotted it away from the Q&A section. He's just quite interested. He said in how the taxonomy was created, developed, and possibly edited to allow guided LDA to work. It's quite a fine-tuning thing, isn't it?
Yeah, that's very true. So how the taxonomy was created is identifying, first of all, you start with the concepts from users' domain knowledge. So you identify, okay, what do you think that the people are going to be talking about in your corpus? If I know that my domain is insurance and most of the comments are going to be about the products that I've sold. So let's say most of the comments are going to be about bodily injury or motor car accidents, etc. So I know already that these are topics, and these are the words that are most likely I'm able to see. Now, so people start with high-level taxonomy, and then the machine helps with algorithms such as Levenstein distance and others to identify words which are closely matching to the words. So then that helps you to build an even larger taxonomy. And once you have that taxonomy of whatever topics that you have, maybe 5 topics or 10 topics, you use that in your guided LDA. And the LDA then helps to build even a better case on those topics. So I hope that is able to answer the question. But it starts with humans, but machines help to augment that taxonomy even further. Sorry, Richard, I can't hear you. Maybe okay, yeah, I can hear you now. Okay.
Just like other, so you mentioned that the loop there in that last or almost penultimate slide there that sort of explains that process a bit more. There's a couple of questions about the user and how user-friendly text analytics software can be. Are there particular features that will always mean the software is more useful?
So I think it's a very wide ranging question. So which software? So there's multiple softwares, and I think although it's quite right because data scientists are able to use a lot of the NLP techniques to analyze data, but the end user has not had a very useful interface to interact and do that. And we've also faced very similar situations where the analysis has been done in Jupyter notebooks or just your in code. But then how do you deliver that to your customers? One of the ways is once you classify those documents, then you give structure to the data. Then you use normal data visualization techniques that you are able to give or deliver to the user. And then there's quite a lot of packages that help you in terms of annotating data. One thing that a lot of people might have used this also. So when we are applying NLP techniques to a lot of corpus to identify which words have played a role in the classification, and I think the package LIME, which is used for interpreting the models, is really good. It highlights the words that it has found to be the most relevant in terms of the prediction. So there's some packages. It's an evolving science, but yeah, it's quite difficult at the moment.
And just finally, there are particular techniques that help show learner engagement in better lights than others. There are particular ways that you can look at good engagement from people learning, from people using it.
Using